Is this upside down? Hi guys, this is Mr. I'm not doing that. All right, good morning, good evening, good afternoon, whenever you're deciding to watch this. This is Mr. Douglas, this is science, and we're going into our next section that is about rotation and revolution. And, before we even get into it, rotation and revolution is actually very easy. We're going to take some notes on it, but essentially, this is rotation. All right, you see that? That's just spinning. That's pretty much all that is. This, get that to stand still, is revolution. When you have this, I'm assuming this is something from Dragon Ball Z, moving around, we're going to call this thing in the center here, we're going to act like that's the sun. All right? And so we are talking about the difference between the two, and rotation and revolution is what causes our day and night, and it's also what causes our seasons. Now, before we get started actually writing the notes, I'd like to thank, this is probably from last year, maybe this year, whatever students I confiscated that from. That really helped out because I don't have any globe stuff here.
Mine!
We're first going to get into rotation. So we're going to write down rotation. And I am sorry in advance for my horrible handwriting. So, rotation is the movement. Rotation is the movement of the earth on its axis. All right. Rotation is the movement of the earth on its own axis. If anything, you could say earth spinning on its own axis. So I'd like you to think about the same way that I spun this little Dragon Ball. That is rotation. So you could draw this by just drawing a circle like that. And we just kind of draw an arrow around it, indicating that this is spinning. All right, we're getting some kind of spinning movement. All right, and Earth is rotating. All the planets rotate on their own axis. Now, axis, A-X-I-S, is just this straight line that is connecting the poles. All right, so we have axis is a straight line connecting the poles. And of course, with Earth and all planets, we got a North Pole, we got a South Pole. I'm sure you're all familiar with the North Pole. That's where Santa supposedly lives.
Santa's coming to town! Santa! Oh my God! Santa here? I know him.
The South Pole, I don't really know what's down there. Nothing. Penguins, maybe. So, you've got the North Pole, you've got the South Pole, and you have a straight line that connects to the top, from the top to the bottom. But our line is actually at a little bit of a tilt. If you've ever looked at the globes, if you've seen the globes in your classroom, you know, the ones that aren't broken, you'll see that the globe is always at a tilt, all right? That recreates that tilt of the Earth's axis. So you're always going to draw it where you have this slight tilt. There's actually a tilt of, and this is going to be for purposes of your test, because they always ask this, there is a tilt of about 23.5 degrees. Now on this one, I'm still gonna show on that 23.5 degrees, we still have this spinning motion that we call a rotation, all right? So Earth is still going to spin around that axis of 23.5 degrees, and one rotation around the Earth, one rotation around this axis is going to take 24 hours. So we've got one rotation takes 24 hours. In other words, that's a day, all right? One rotation, 24 hours, that is one day on Earth, all right? I say on Earth because you guys are gonna see in some later videos, depending on what planet you're on. I think Venus, it takes like 214 days equivalent to Earth. Like, it spins a lot slower. There are planets that spin a lot quicker. So a day there might only be 10 of our Earth hours. All right. So that's what controls our days. Rotation controls how long the day is going to last. This spinning motion controls how long that the day is going to last. So make sure you know those key points. Rotation is the movement of the Earth on its own axis. The axis is that straight line that is connecting your North Pole and your South Pole, and there is a tilt of 23.5 degrees. Why is that important? Because we're going to test you on it. So make sure you know that. And one rotation around this axis is 24 hours. So one rotation is our day. This rotation of the Earth is what causes our days. I have gained a newfound respect for Miss Washington and how she was doing this, because this whole tripod thing, you know what, never mind. Let's get to the second point. So the second point that we need to know is revolution. Revolution, all right? And revolution is the Earth's movement around the sun. I had a brand lapse there and I forgot what I was about to say. So, revolution is the Earth's movement around the sun. So if I were to draw revolution, it would be something like this. We'd have the sun here. I'm going to say that that is the sun. Oh man, my handwriting's horrible. And let's say, and the Earth is going to be smaller. All right. You know what? You know what? Ugh.
My son, it is forbidden for you to interfere in human business.
One thing I do know, son, and that is you are here for a reason.
All those things I can do, all those powers, and I couldn't even save him. Hi. Don't bother, I think it's dead.
Sure, it's dead. The problem with Men of Steel, there's never one around when you want one. You know what happened to me while you were off flying around? I was almost in an earthquake. I had this gas station blow up beside my car. There's telephone poles falling all over the road. I'm almost killed, and I topped the whole thing off. This stupid car runs out of gas.
I'm sorry about that, Lois.
You know
But I've been kind of busy for a while.
Ugh. All right, movie magic. I'm fixing that. So we're going to make our sun large. And we've got our Earth here. All right. And this is the Earth's movement around the sun. Now, that is our revolution around the sun. Now, remember, as this Earth is revolving around the sun, it is still rotating around its own axis. So we're still going to have this 23.5 degree tilt, and it's still going to be spinning as it is rotating around. So the spinning, remember, is our rotation. The movement around the sun is our revolution. Spinning, that rotation, is going to cause the night and the day. Our revolution is going to be cause a year, because it takes 1 year for Earth to revolve. So 1 revolution takes 365 days. Meaning it basically just takes a year. Now, it's the same as when we're talking about the other planets. Some planets are a little bit further out, so a revolution around the sun is going to be longer than a year, an Earth year. Some planets are closer, so a revolution around the sun is going to be shorter. So if we're counting by Earth times, there could be a planet that's far, far out, and it might take 300 years to go around the sun. If we're going by Earth years. And there could be a planet that's close, and it might take 6 months for it to go around the sun. So that is how we're looking at the years. Now you can keep writing on this page down at the bottom, but I'm going to flip to a new page because this tripod's annoying. All right, me on a new page. Let's go back to talking about revolution and the tilt. All right, so remember that tilt of 23.5 degrees is the reason we have seasons. All right, that tilt coupled with our revolution. All right, that is the reason for our season. So I am going to again put our sun here. All right, and I'm gonna put Earth right here. And I'm still gonna put our tilt on here. So we still got the tilt. We have, I'm gonna put the equator on here though. Now remember, the equator breaks up Earth into the northern hemisphere. So you got the north, and you got the south. Now, the sun emits heat, it emits light, and it's all headed towards Earth. All that heat, all that light, all that radiation heads towards Earth, all right? And the way that it hits Earth, you see with this tilt, the south is facing more towards the sun. So the southern hemisphere right now is experiencing summer. All right, which means the northern hemisphere is experiencing winter. That looks horrible, but I'm gonna write that again. And somehow I made it look worse. Either way, look, write it how you want to write it. It's winter. Y'all know what winter looks like, all right? Now, remember, there's still a revolution. So, this is here. We've got a revolution of the Earth. It's going just like this around the sun, all right? Same tilt, though. So I'm gonna put that tilt in. I'm gonna put my north and my south. So I've got the northern hemisphere and I've got the southern hemisphere, all right? But this time the north is facing towards the sun. So the north is experiencing summer, while the south, here we go, the south is experiencing winter. Much better handwriting on my part, much better. So you can see that as the Earth rotates and maintains that tilt of 23.5 degrees, the way that the sun hits the Earth is why we have our seasons. So that's why we're gonna cycle through summer, winter, spring, and fall. All right, so this week, that is what we're gonna be looking at. The rotation of the Earth, the revolution of the Earth around the sun, how that causes the days, how that causes these particular seasons, and that is pretty much what we're gonna be going through for the whole week. And then also remember, we're going to be incorporating the moon. All right. So those are your notes for today. Copy those. Make sure to upload them into the folder and have a good day.